So today we are talking about graphing equations. So the first thing we want to do is complete the warm-up, which is on your lesson agenda. So pause the video while you complete that warm-up. When you're done, go ahead and hit play and we'll get into the lesson together. All right, so at this point you should be done with the warm-up. So let's go over it. The first step would be to label your coordinates. So I've labeled my coordinates x1, y1, and x2, y2, meaning the first x and y coordinate and the x and the y coordinate for my second point. Then all I have to do is replace or substitute those numbers in for their corresponding variable in the formula. So our slope is equal to, in the top, I have 5 plus 7. How did I get 5 plus 7? Isn't this supposed to be subtracting? Well, yes. However, originally what I would have gotten is 5 minus negative 7. I'm subtracting a negative. When I subtract a negative, that becomes a positive. So that's why I have 5 plus 7. Then in the denominator, negative 1 minus 3, which results in 12 over negative 4, or negative 3 when we divide. So this is Learning Target 12. This is lesson 4.3, part 1. Part 1 is all about graphing. Part 2 will be focused on writing equations. So our central questions for this lesson are: what are the three different forms to represent a linear equation? And then how are equations of lines graphed? And again, we're going to focus in on graphing for this lesson. So example 1, we want to use a table of values to graph the equation y equals 3x minus 2. So what this means is I'm going to take these values of x and I'm going to plug them in to the equation where I see x and see what happens. What do I get for y? So when I replace x with negative 2, I get 3 times negative 2 minus 2, which equals, well, 3 times negative 2 is negative 6. Negative 6 minus 2 is negative 8. So negative 8 goes in the table for y. Then what is y equal to when x equals negative 1? Again, I'm going to plug that in for x. So that equals 3 times negative 1 minus 2. Well, that's negative 3 minus 2, which equals negative 5. And again, what if I plug in 0? Well, 3 times 0 is 0. 0 minus 2 is negative 2. Plug in 1. 3 times 1 is 3. 3 minus 2 is 1. And lastly, I'm going to plug in 2. 3 times 2 is 6. 6 minus 2 is 4. So now I have completed my table. So I really have 5 ordered pairs. My first ordered pair is negative 2, negative 8. So I'm going to go left 2 and down 8 on my coordinate plane. Then the second ordered pair is negative 1, negative 5. If x is negative 1, I go left 1. And if y is negative 5, I go down 5. So left 1, down 5. Then 0, negative 2, I stay in the middle and go down 2. 1, 1, I go right 1, up 1. And 2, 4 is right 2, up 4. At this point, I'm going to draw a line through these points, making sure that line has arrows on both ends because it's a line that continues forever in both directions, not a segment. And I'm done. I have used that table and the equation to graph that equation. So your turn number 1, I just want you to practice completing the table, filling in the table, using the equation, and using the values that were given. So for the first one, our equation y equals 5x plus 2, plug in each of these values of x into the equation and see what y is equal to. You're doing that for each of those 3 equations. So pause the video while you work on that. When you're done, you can hit play and I will go over the answers with you. All right, at this point, we should be done with your turn number 1. So here are the answers. When I plug in negative 2, negative 1, 0, 1, and 2 into the first equation for x, I get a y value of negative 8, negative 3, 2, 7, and 12. When I do the same thing for the second equation, the solutions I should get are 5, 4, 3, 2, and 1. Keep in mind, a common mistake here is to forget that there's a negative there. So like when I plug in -2, it's negative 2 plus 3. So that's really positive 2. Negative times negative is a positive, so positive 2 plus 3, which is why I get 5. So just be mindful of the negatives. I always use parentheses whenever I'm plugging in values in for a variable. And then for the last one, we should get 2, -2, -6, -10, and -14. All right, so a type of line that you might see, or that we might be graphing, or that we might be writing the equation for is a horizontal line. So a horizontal line occurs when we have an equation written as y equals some number. So if y is equal to just a number, just a constant term, that's when we get a horizontal line. Because our slope, because there's no variable x, our slope is 0. And when we have a slope of 0, we're not going up, we're not going down, we're staying flat. So an example of this is y equals 4. This graph is actually the graph of y equals 4. Now why is that? That's because the equation y equals 4 is really saying no matter what value of x we have, if x was 0, well, there's no place to plug in 0 in that equation. So if x is 0, it says y equals 4. Well, what if x is 4? What if I said x equals 4? Well, there's no place to put that value of x. So if x is 4, y is still equal to 4. And in fact, no matter what value of x I choose, I could pick x as -10, y is still at positive 4. So we get this straight line, this flat line, when we have y equals a number. Then for a vertical line, it's just the opposite. That's when x is equal to a number. So that means that the value of x is never going to change dependent upon y. It is independent of whatever y is equal to. So y could be 4. We could be up 4. X is still equal to -6. Y could be 0. X is still -6. Y could be -8. X is still left 6 or -6 on the x-axis. So we get this vertical line that occurs. So those are two kind of special equations that you would see, horizontal lines and vertical lines. So based off of what we have done so far, you want to complete self-quiz number 1, which is again on the back of the 4.3 part 1 lesson agenda. I have already created these two tables for you. Okay, so I've given you these tables. So go ahead and first jot these down. And you're going to use those, plugging in the values of x that I started you off with, and figure out what is y equal to for each of those values of x. So what is y here, here, and here? What is the value of y when x is -2? How about when x is -1? How about when x is 0? Once you have completed those tables, you're going to go ahead and graph both of these equations on this coordinate plane. So there's going to be two different lines. Make sure that you've connected all of the coordinates on that line and make sure that that line has arrows on both ends. That concludes this part of the lesson.